Uh, Good evening, everybody. Now, what I'll do is I'll be starting up with the demo, right? And few of the questions which are asked, like what will be the platform where actually we will be doing installation, right? Whether it will be Windows or whether it will be Linux, right? You'll get answer to all that once we move forward, right? Now, first objective of this part of demo is to ensure that we all understand what big data is, how big data is going to be opportunity. So it's a common term now that we read in lots of books today. Objective of this particular demo is to make you understand big data from various perspectives, that what role I will be playing if I am an administrator of big data, what role I will be playing if I am data scientist, what role I will play in case if I am a developer, right? And a mix of big data frameworks can be used in order to derive architectures, right? And probably when we start up with our case studies, we will see how actually big data will have impact over various domains, right? When it comes to manufacturing, when it comes to advertising, when it comes to power sector even, and when it comes to various domains, e-commerce domain, right? How actually big data is going to help enterprises to gain insight from the data which is available, and in what way that analytics is going to increase their profitability in market and also to be one of the winners in their area as compared to their competitors, right? So we'll start now. If you have any questions, you can definitely type in. Now let's first understand what big data is, right? I don't go with slides which are already made, right? Because audience in each and every batch, or whenever we talk in webinars also, they are very, from diversified background. So some of the slides we keep empty in order to ensure that we punch in certain relevant things there. Right? Now, today, if you see, organizations or enterprises are run by their applications, right? An enterprise always prefers to have good applications in order to ensure that. Can we mute everyone, Anthony? Because I'm getting some background noise. Chakravarti, can we mute? Yeah. Balakrishna, can you mute yourself? Okay, I'll be. Anthony, can you mute? Because I don't have privilege to mute them.
In classes గురించి మాట్లాడుతున్నా నేను ఆయన.
Okay, thanks. Okay, thanks. Thank you. So now what we are going to understand here is what actually is an enterprise application and why do we need this big data, why this big data came into picture, right? Now, basic objective of enterprise is to process the data and provide the right information to various functional units so that they can decide that what should be their next action or plan in order to ensure that their task they are able to do in better way, right? Other important thing that you need to understand here is that value of data is being identified by all enterprises now. Whoever does better analytics on their data, probably they will lead their competitors, right? So value of data now is being identified because now almost everyone is using some or other device, some or other application, right? Which is going to populate the data, which is going to inject that information into cloud. When I say cloud, don't take the literal meaning of cloud as a technology. When I say cloud, you can treat it as a data lake, right? So companies are now reframing or restructuring their architecture in order to ensure that they are able to do proper analytics on huge volume of data, which is being available through various injection points which are available on www. For example, social media, then you have Twitter, then you have various applications which are contributing to huge amount of valuable data being accessible to almost all enterprise applications so that they can go do their analytics, identify the right customer and propose them even the right product on basis of trend, on basis of predictions, on basis of past behavior of that particular customer or that particular client, right? But unfortunately, what is happening? Too much of data is coming into the data lake, right? In other words, volume of data is increasing, right? When volume of data increases, do you feel that your enterprise will always be able to manage that volume? No, right? So first task that you have to do here is plan what volume of data your enterprise can manage, right? What volume of data you can manage or your enterprise can manage, right? Is your enterprise capable enough to take care of current volume? And what about futures? Because volume of data is going to grow. Is your enterprise is having some plan in order to manage the growth of volume which is predicted in coming near future? If yes, do you have the right solution for that? Right? So you have to plan what volume of data is going to get injected and how actually you will be managing it. Now, second important thing that you need to understand or realize is you see daily different variety of data is coming into picture. Like if you see, you have to process images, you have to process videos, you have to process audios, you have to process text documents, you have to process XML, you have to process JSON, you have to get data from database, you have to get data from ERPs, you have to get data from data warehouse, you have to get data from SAP, you have to get data from IBM mainframes, you have to get data from sensors, right? So you see, variety of data which is being made available to your enterprise is also increasing day by day, right? So you need to again do a planning that what about variety? Will my enterprise, current enterprise, understand all different variety of data which is being injected or which is being populated and being made available in the data lake, right? So plan the variety, right? And check the readiness of your enterprise to understand various variety of data. So this becomes second important factor that you have to consider when you are planning to mine data and do analytics on that data to derive some value for your enterprise, right? Then one more again important thing that we should not miss, because these all are going to provide us good input in order to decide our architecture, and that is velocity. Velocity means what is the injection rate? Is at what rate data is coming in your system, and do you have plan in case if injection increases, because it is bound to increase. Traffic on www is increasing. People are connecting to www using various devices, right? So we need to be ready. We need to plan. We need to go and test our enterprise, whether my current enterprise application is ready to manage the volume which I have predicted, whether my current enterprise is able to process all different data or type of data which is being injected in something called as data universe or data lake. What about velocity? Is my enterprise ready to provide the right bandwidth in order to support the rate of injection which is happening today, right? So Twitter, or you say even Google, or you say even Facebook, right? They have to upgrade, they have to scale up their system in order to manage growing number of users who are using these different applications, right? Now, if you feel that volume which my enterprise can manage have a limitation, and in case if I'm going to increase or scale up my current architecture, it is going to cost me a lot. So you have to search some solution which can provide you capability of increasing your capacity or scaling up with minimal cost, right? Because cost is a factor which everyone will always keep in mind. Same is the case with variety. What I will do in case if my current enterprise is not able to understand or interpret a particular kind of data, definitely what I need to do, I need to go and do some architectural change and add some element which is capable of understanding or storing data of various types. Same is the case with velocity, right? If I'm scaling up my current enterprise and if I scaling it up, keeping in mind velocity, my cost is increasing, double-fold or even triple sometimes, right? So now we need to search what is that which we can do with minimal cost and get benefit of scaling up our architectures so that we can manage, we can plan volume, variety, and velocity, right? And we can adopt various type of data by saying that we are open to any type of data, right? by ensuring that whatever data is going to come inside or it is going to increase volume for next 10 years, we are prepared for it, right, with minimal cost, right? So cost is a factor, but when data volume increases and when variety increases and when velocity rate is identified, what you will be able to do? You will be able to derive value of data, and this is what is final objective, right? So once you have made your architecture ready to support huge volume of data or expected volume of data, variety and velocity, then you have to plan how I will get value of the data, right? For that, you will have some identified use cases, right? That, okay, fine, this is what is analytics that I'm going to do, and this is what will be the output, and in this way it is going to support my business, right? So as a data scientist, you should be capable of deriving the right value of the data and then supporting your company or your enterprise to actually go and use that particular value in order to increase their business or increase their productivity, right? For example, think of power sector. You have many grids, right? And power is supplied from many grids, right? Now what happens, you did predictive analysis and you found that at a particular point of time, load on one grid is too much and load on other grid is too less, right? Now this particular predictive analysis will help you to distribute the load across your grid equally, right? Which definitely makes sense for a company which is there in energy sector, right? Similarly, analyzing the trend of customer, how actually power usage is being done, right? Or analyzing the output of smart meters, right? So you have actually various use cases which you can suggest clients or you can suggest enterprises, but all those use cases objective is to ensure that you are able to derive the right value of data, right? So I'll write here value of data means how to extract value from existing data universe. When I say data universe, there are other terms also. We say data lake. Why we say lake? Because data comes from different sources here, right? So now, why I'm talking about this? I'm talking about this just in order to define big data. Now, please understand, big data does not have a fixed definition. Whenever your enterprise says that now I am not capable of managing the volume which has been injected to me, when your enterprise says that variety also I cannot incorporate dynamically, when it says that I may not support the right velocity or rate of injection after 1 year or after a few years, right? And when your architectures or architect, or you say when your architecture or enterprise application says that I have limitations in extracting the value of data because I have a predefined schema, right? So definitely from predefined schema, you have a fixed set of value that you can extract, right? So when you find that there is problem which is coming because of volume, there is problem coming because of variety or velocity, or you are not able to extract the right set of data, it means you are in a trouble. And that trouble is big data trouble, right? Your enterprise has to be changed. It has to be realigned. Something needs to be done in order to ensure that whatever troubles you are facing because of volume, variety, velocity, and value of data, it can be turned into opportunity, right? And that's where you have to come up with big data solutions, right? So we are going to talk about big data solutions here. But before that, let's have a good definition of it. Big data is term for collection of data sets so large and complex that it becomes difficult for your existing architecture to manage, right? Or traditional tools to manage. So only solution is scale up. And scaling up may be costly if you go with database scaling up, or when you go with other traditional tools scaling up, right? So scalability incurs lots of cost in existing enterprise. It means you are facing issues of big data, right? Fine. So now we identified what big data is. What about big data solution now? How we are going to manage all this? In order to manage all this, first you have to do what? You have to identify what all different type of big data technologies are there today, right? So let's group it into two different technologies. One is operational big data, and second one is analytical big data, right? Now, we need to understand what is this operational big data. Have you ever heard about real-time analysis? Have you ever heard about real-time analysis? You might have heard, right? It means I want to do real-time analysis. I mean, data is getting injected, and whatever is the data which got injected, now I want to make it available, and my analytics should include that particular real-time injection of data, right? For example, weather forecast, or you say stock exchange. Whenever there is some change, immediately that change need to be applied, and you should be able to display new trend of price on that particular stock to your consumers. Or you can say sensors. Sensors are creating data every second. That data is getting injected in your system, and you need to make that data part of your analysis. And that is where you need operational big data solution, right? And operational big data solution actually provides operational capabilities for real-time interactive workload, right? Where data is primarily captured and stored. Fine. So you need to think from perspective of what I need to do in case if injection is happening and I need to do real-time analytics. What should be my data model, right? How actually I need to maintain structure of data so that in case if some data comes, I'm able to easily adopt the data in my data structure, right? In order to help you in doing that, you have various frameworks today. One of them is MongoDB. You have Cassandra, you have Neo4j, right? So we are going to cover MongoDB and Cassandra, right? So you need to be very careful in identifying technologies which you are going to make part of your architecture. Now comes second important technology or group of technology, which we call as analytical big data. Analytical big data means you have history of data which is stored. You don't have frequent writes in that data. For example, population, doing analytics on current population. Now, you know, every country have their own predefined number of years when they will go and they will count number of people who are there in country, like especially country like India and all, right? It's not daily runtime injection of population is done, right? So any historical data which is stored somewhere, and then you just do analytics. You don't go and update, insert, and delete. You just make the data available, and then you do analytics, right? For example, you say customer behavior in a particular company. So you will take 5 years data, and then you will do analytics. You will not be taking into consideration new customers who are coming and who are doing purchases, right? So when your need is to do analysis on a historic data, and provide some kind of value to your enterprise, you need technology which provides you write once and read multiple times capability, right? There where analytical big data solution comes into picture, right? Systems that provide analytical capability, right? Complex analysis that may touch most of all data, right? It means here, real-time data is not required. You have history of data, and now you are doing analysis on it, right? Framework that is used in order to help you in doing that analytical big data activities is Hadoop, right? Now, why this course contains two? Because today companies are smart enough to identify that they do have big data problem, but that big data problem is not only related to analytical part. It is also related to operational part. So most of the companies are now going with combination, Hadoop plus MongoDB, Hadoop plus Cassandra, right? Fine. So these two types of big data solutions are there. In this course, you will come to know how we can integrate these capabilities so that your big data solution have capability of operational big data as well as analytical big data solutions, right? Okay, so I feel that now two things are clear to you. One is what big data is. Second is how to group big data problems and identify the solution. right? So you have to identify your problem, whether it is operational in nature or it is analytical problem, and then probably you are going to adopt 1, 2, 3, 4 or various technologies, and you are going to make it part of your architecture, right? Now, since this is demo, I'll directly come to something called as what is this Hadoop, right? One definition I already gave you, and that is Hadoop is an analytical big data framework, right? You should not be surprised to know that Hadoop is written in Java, right? Now, in what way Hadoop comes and provides benefits of managing big data, right? That is what is the big question. In order to manage big data, I'm finding some background noise. Can you just mute, Anthony? I'm able to hear some background noise. Shiva, can you mute yourself? Okay, thanks. So now we are going to talk about how actually Hadoop came and it commits that I'm going to help you in managing your big data. It's very simple. Hadoop came up because of problems which was being faced by Google and Yahoo. Because Google was managing big data, right? It has to take care of providing search, right? And daily new data is getting added to their search repository. So it has to find some way so that it can manage that huge volume of data which is getting created, right? So in order to get that particular problem sorted out, Hadoop, you say, Google came up with something called as a file system. It came up with file system. What I'll do, I'll insert a new slide here. I'll write here motivation for Hadoop. It is GFS, which stands for Google File System. So Google actually came up with a unique file system called as GFS, which was distributed in nature. When I say distributed in nature, you need to understand that this file system is not there on one box now. This file system is spread across multiple boxes. This is the reason why we call it as distributed file system, right? Features which was there in GFS were really very unique. One of them is auto recovery. It means that in case if something fails, your GFS will try to automatically recover from that particular problem, right? Because now here you don't have 1 box or 10 boxes or 100 boxes. You have thousands of boxes, right? Because of some reason, some box may be down. When I say box, you need to understand machine, which is part of your GFS, right? So in case if something is wrong, your GFS internally automatically starts up recovery process, right? So auto recovery is also one of the unique features which was added in GFS. Apart from that, scalability, right? Means you can go and you can add nodes dynamically. Right? I mean to say that you can add nodes dynamically. So when you are adding nodes dynamically, your existing file system will not have impact, and you can scale up as and when needed. So you can say elastic. Grow once need is identified. So you see here, administrator's intervention is reduced because it is doing what? It is providing you capability of auto recovery. Your scalability feature supported by GFS is also horizontal scaling up, right? And this scaling up of system is dynamic, right? And also elastic. It will grow once need of more storage is identified. Now, this unique feature of Google was actually source of inspiration, which actually gave birth to Hadoop's first core component called as HDFS. Now, what is HDFS? This is again a file system which has been motivated by GFS, which is distributed in nature and have all capabilities of GFS, which you can say is distributed in nature, auto recovery feature, dynamic and elastic scalability. which is part of HDFS as well, right? Now, don't you feel that if you scatter your data to too many nodes, analytics becomes challenge, right? Because your data is stored on various nodes, right? Your file, which was too huge, was split into n number of blocks, and now it is present on multiple nodes. So analytics becomes a challenge. But don't worry, Google worked on that as well, and they came up with a unique algorithm, a unique programming model to do analytics. And that programming model was called as MapReduce, right? So you can say this was programming model which was adopted to do analytics on GFS. Okay, so this is a programming model. Your Hadoop gets its second component from here, and that component is called as MapReduce engine. When I say engine, you should understand that MapReduce engine will interpret and execute MapReduce programs. So this is what is benefit that you get. So now we are ready to define what Hadoop is. Hadoop is a big data framework, right? Written in Java and has two core components. First component is HDFS, which is all about how data will be stored, its file system, distributed file system. And second important component is MapReduce. MapReduce engine has capability of executing MapReduce programs. And what is the objective of MapReduce program? Objective is to help you in doing analytics on data which is present on HDFS, right? So motivation of Hadoop has come from Google. Later Yahoo also joined the race, right? And with contribution of many other companies who were into big data domain, you got a product called as Hadoop, which was contributed to Apache as an open source, right? So it's not necessary that you have to go with Cloudera or Hortonworks. You can build your own big data stack using open source Hadoop, right? So I feel that one thing is clear to you, and that is Hadoop is combination of two important components, core components. One is MapReduce, second one is HDFS, right? So here we came to Hadoop architecture now, where we are able to see that there are two different versions of Hadoop now, right? Versions are going to get increased the minute you will find changes or improvements which will be done in this framework, right? And if you see here, you have two important components of Hadoop 1.0. One is HDFS, which is unique, reliable, redundant, right? And auto recovery supported file system, which spans across different boxes. Then you have MapReduce, which is an engine to interpret or to execute your analytical logic, which your developers will write following an algorithm or a programming model called as MapReduce, right? Now, if you see Hadoop 2.0, it has some extra component. Now, I'll be brief here because all these we are going to discuss in detail in upcoming sessions, but in order to just set the stage and make you understand the basics, I will be very concise, very brief on this, right? Hadoop 2.0. Now, I'll ask you one question, Stephen. This question is very simple. Can you formulate all existing analytical problem into MapReduce algorithm? Don't you feel that we are making life of analysts complicated? We are asking them to do everything using a single algorithm called as MapReduce, right? And this was the challenge now. That how we can translate all problems into just map and reduce. So when Hadoop 1.x realized that it's a constraint now, I'm asking you to just use one software in order to visualize the data, right? It's a constraint. So when Hadoop 2.0 was designed, they kept this into their mind that yes, fine, I agree, or we agree that only MapReduce programming model is not the approach. You may have different other approach also. So now you need an architectural change in Hadoop itself. It has to be made capable of understanding not only MapReduce, but various other data processing programming models which are being contributed by open source. To name some of them, you have Tage, you have Storm, you have Tage, you have Stringer. There are various now which are there in market today. Right? So Hadoop 2.0 added capability to your Hadoop, where now it's not only that you will be using MapReduce, you have various other programming models which will be supported by your Hadoop 2.0. Right? This is the reason why we have Hadoop 2.0. And component which makes it possible is Yarn, Y-A-R-N. Right? So Yarn says that let's not couple cluster management and data processing. Let's decouple it. So entire cluster management will be done by Yarn, and data processing now is MapReduce, others, where others will contain a number of other open source technologies which are there in order to help us in analytics. Right? So this is how you will be able to decide, shall I go with 1.0 or I should go with 2.0? Right? Now one obvious question which comes into mind here is, what about if I have written all my analytics keeping in mind Hadoop 1.0? Don't worry. Hadoop 2.0 understands everything which you have written in Hadoop 1.0. Right? So you can say backward compatibility is supported by your Hadoop 2.0. Right? So decide which version of Hadoop you will go for, 1.0 or 2.0. Is that clear? It's clear, right? Viraj, is that clear? Okay, fine. Now let's go and talk a bit about HDFS, right? I'll just insert here new slide and we'll talk about HDFS. It's a file system. And this file system actually adopts master-slave architecture. Now there are other architectures also, but HDFS in Hadoop adopts master-slave architecture. Now what do we mean by master-slave architecture? Master-slave architecture means master will take responsibility of managing all the requests of client. And what about slave? Slave in HDFS stores, or you can say his responsibility is to store the data. Right? In other words, I am telling you that master will not store any data. Right? All data will be stored on slave. In Hadoop, this master is called as name node. And slave is called as data node. Where now name node maintains metadata, means information about your Hadoop HDFS cluster. I'm calling it as cluster because you have multiple boxes. Some boxes will have data nodes and one box will be name node, right? So name node is the master who manages the entire cluster, and your data will be stored where? It will be stored in data node, right? So typically I can conclude here by saying that HDFS is combination of two components. One is name node and second one is data node, right? Or data nodes. Fine. Whenever client will make request to read data or to write data, that request will be made to name node. And it is now responsibility of name node to decide that on what all data nodes data will be written. So name node identifies the right set of data nodes and informs client that, see, you can write your data on data node 1, 2, 5, 6, 7, whatever, right? And then client connects to those data node and will write the data, right? Fine. So that's what is HDFS. It's combination of two components. One is considered as master, other is considered as slave, right? Any confusion here? I'll be going to more depth once we start up with actual session. As of now, I'm just trying to make things clear to you. Terminology is clear to you, right? Now, one thing that you need to always keep in mind, planning is very important, right? So you have to plan
what configuration must be there for master and slave, right? Interesting here is Hadoop works with commodity hardware. When I say commodity hardware, it means you don't need specialized hardware to work with Hadoop, right? And you don't need to buy licenses of software because you can work on Linux. Let me say Linux. Right. So Hadoop works with commodity hardware, right? And you can use any operating system in order to format and keep the SDFS ready for it. You'll come to know more detail once we move there. It's clear, right? So plan what configuration must be there for master and slave, right? I'm clearly telling you that name node will not store the data. So storage, okay, it can be less, but clients are first interacting with name node. So processing power should be more because you may have thousands of clients requesting name node for read and write operation. So you have to decide that capacity of name node in terms of compute, in terms of storage. Similarly, capacity of storage and compute for all your data nodes, right? And this planning we will do because we have to consider n number of things here: network, what type of network you are in, right? What is the switch that you are using? What is capacity of the switch? Right? Whether you have rack-based configuration or non-rack-based configuration. There are many factors which will be included in planning. And that is what is going to be our first session, planning and installation of Hadoop cluster, right? Now, what next? Next is, what about MapReduce if we consider 1.0? In MapReduce, Hadoop actually manages MapReduce algorithm by using two other processes. One is called as job tracker and another one is called as task tracker. The responsibility of job tracker is again what? When you submit your program for analytics, your job tracker schedules the job. In order to ensure that your job executes fast, your job tracker splits job into n tasks and allocate each task to something called as or someone called as task tracker, right? That's what is responsibility of job tracker. So whenever client submits some program for execution, your job tracker assigns it a job ID, schedules it for execution. When I say schedule, again making resources available. Then split it into n number of manageable tasks and then allocate those tasks to be executed by task tracker or task trackers, right? And what is task tracker? Executes the task, right? So what all you have to configure now? If I ask you to, okay, fine, go and configure Hadoop. What are the 4 important things that you have to configure in case if you are using Hadoop 1.0? Yeah, just guess. First is file system. What are the 2 components of file system that you have to configure? Master and slave, right? And then you have to configure what? Job tracker and task tracker, so that whenever job is submitted or delegated, it is distributed properly for execution, right? So this is what is objective of Hadoop, and these are different components actually which makes up your Hadoop, right? So this is what you will be doing. Yeah. Now, problems with Hadoop 1. Madhur, I'll come to you. There are some typical problems which exist with Hadoop 1.0, and one of them is single point of failure. Unfortunately, in Hadoop 1.0, you cannot have two name nodes. Okay. Hello. Am I audible? Are you able to hear me? Okay, fine, thanks. So now if you see problem with Hadoop 1.0, and problem is single point of failure. It means there was no way where you can have two name nodes so that in case if one fails, other can take over. And you know, this problem was resolved in Hadoop 2.0, where you can have two or two plus masters. At any point of time, one master will be active and rest of them will be standby. As soon as active goes down, standby will take over, right? So how to set up, you say, highly available Hadoop cluster, that is also part of coverage. I'll be telling you how you can have two masters and how you will decide to have transition from master, active master to standby. It means how to promote standby to active, right? All that is part of coverage, right? Second was MapReduce was not extensible. It means it will support only one type of algorithm, and that algorithm is map and reduce. This was again eliminated in Hadoop 2.0, right? So most of the solutions today are Hadoop 2.0, right? And that is what I will ask you to adopt as well. But yes, you need to understand how to have transition from Hadoop 1.0 to 2.0, right? So when I will do installation and configuration of Hadoop, there I will tell you how you will plan your architecture, how you will plan an architecture without, you say, failover support, and how you will configure an architecture with failover support where you can have multiple name nodes, and planning that how transition will happen from active to standby, right? Okay, fine. So now what I'll do, I feel that it's almost, what is the time? If you see it is 10:47, I'll not take much time. Let me show you how simple it is to install and work with Hadoop, right? What I am doing is I am using a box here, and that box is Ubuntu, right? You need not worry because our course tells you different, we'll talk about different flavors of Hadoop. And along with different flavors of Hadoop, we will also tell you how to do installation on various other operating systems. Right? As of now, it is Ubuntu. I will also tell you how to do it on Red Hat, right? And one of you asked that whether it is possible to have it on Windows or not. Yes, it is possible. So how to do it on Windows? Your HortonWorks have made it possible, right? So now let me go and execute something here. Objective of this 10 minutes of demo is to show you how simple it is to install Hadoop and manage Hadoop. Regarding course, we are going to cover three different flavors of Hadoop. One is Cloudera, popular one. Second one is HortonWorks, and third one is Pentaho, right? All three we are going to cover here. But yes, coverage will be of different types. Some will be in form of case study, some will be in form of cell-driven assignment, and some will be demonstrations that I will be doing, right? Now, Hadoop is a framework written in Java. So in order to ensure that I'm able to install Hadoop, I need to first install what? Java, right? So assume that you went to a company and you got a task that I have to install Hadoop. Okay? First thing that you will do and go and check is whether this box has Java or not. So I'm writing here javac.version. It tells me, boss, there is no Java here. Right? So I have to plan now installation of Java, which is heavily dependent on your operating system, right? For example, Ubuntu. In Ubuntu, what we do is we pull Java from repository and then we install it. But first what we need to do is we need to add the repository. And you see how to add the repository. You'll be getting these small tools from me. so that you need not remember the commands, right? Because I know it's difficult. So what I'm doing first is add repository to your Ubuntu, and that I'll do by using this. Now I have already prepared these commands, so you need not look for here and there. You'll get everything. You need to just go and try it out and create your own toolkit, right? I'll press enter, and you see now it has added repository, and I can go and I can install what? Java 7, Java 8. Before you decide which version of JDK you have to install, you need to go through the documentation of your Hadoop. If you are using Cloudera Hadoop, go and see which is the right fit for your current version of Cloudera, right? So before you plan which JDK, you just don't go and install JDK like that. Like, you have to have your plan that, okay, I'm going to install Cloudera Hadoop, and Cloudera has tested their Hadoop on 6 or 7, not on 8. So better is to go with 7, right? So once you have added this repository, your next task is to go and make that repository available with the required software that you want to install. So I'll just go here and use second command, that is update. This will pull now Java and make it available in your local repository. Now, third step is to go and install Java. For that, we will have this. So what normally we do is we try to do installation together with people who are attending, right? So this will install Java. So after seeing here installation, what I do is I share these commands with you and I make you do it on your boxes also. So I'll take you step by step, ensuring that Hadoop cluster is available with every one of you. Fine. Now let's go and test it. Java C minus version. It gives me a version. Java, and I'll go and use minus version. Now this gives me version of Java. Always ensure that your Java version, which is interpreted, is similar to this. This is one of the good practices that you have to follow. Okay, so Java is installed. Now, after doing this, what usually I do is I take up the history of command, I copy it from here, and I paste it on the chat box so that you can also go and do installation at your boxes. Right? So you see, all steps are marked here. Step 6, step 7, step 8, and then check. Right? So this is what is approach usually which I follow or we follow in order to ensure that we all have installation and configuration done, so that you can use your extra time in doing analytics or in doing other administrative tasks. Right? Now what is our next objective? Next objective is to go and install Hadoop. Right? In order to install Hadoop, what we do is we decide our distributor. Right? Whether we'll go with Cloudera or we'll go with Hortonworks. You need not worry because I'll be covering both flavors here. As of now, we will go with Cloudera. Right? Now, when you go with Cloudera, okay, fine, Rishikesh. This command number 7 does what, right? You have added here repository. It means now your Ubuntu is aware about this repository, but it has not fetched installation directory or installation file or installer from there. When you do this sudo apt-get update, it goes and pulls the required packages from the repository. If you will not do this, it will not pull. Okay? Is it clear, Rikesh? Okay? Now, same is the task that you have to do in order to install Cloudera Hadoop also, right? I will not move into what is Cloudera Hadoop because there again I have to explain you that it comes with two different components. One is called as CM, Cloudera Manager. Second one is called as CDH, which is Cloudera Distribution of Hadoop. Here I am just showing you how to install Cloudera Hadoop so that you can understand the mode of training. Okay. So details anyhow will be there when we start up with our actual training. Right. So now let's move forward. In order to install Cloudera or Hadoop, Cloudera Hadoop, you need to again have what? The right repository like we had it for Java. Okay. And now this time what we will do is we will go and add that repository in a file so that it is there with us. We'll create a file. See, I'll clear screen and I'll go here and paste it. I'll do all this again like in actual sessions also. And now I'll insert the URL from where it has to fetch. And please understand, this is different for different operating system, right? This is for Ubuntu. So if you want CDS to be installed on Red Hat, you have to get a different package, right? Fine. So just a caution that this will not work with all operating systems. Each operating system will have its own repository, right? We are just going and pasting it here. Be careful because this has to be as it is. Even one spelling mistake will create problem. After doing this, we will save it. Sorry. Now file is saved. Next, again same task. We have to go and do update so that it goes and pulls Cloudera packages from here. But be careful. What if someone else has written their own Cloudera and you are going and you are getting that Cloudera, right? So in order to ensure that you are downloading packages from the right source, Cloudera provides you a key that you need to add to your system, right? And in order to add that key, it's very simple. You have to use this command. Right, so I don't expect you to mug up this command because this is bound to change and versions will change. But yes, steps need to be clear to you. If you see now, key is added. Now, this will guarantee that you are getting Cloudera from the right source, right? It's not from any source. You're getting it from right source. Okay. So what next? Pull it from that source by using sudo apt-get and what? Update. This will pull Cloudera libraries from there. And that's what it is doing. It is reading packages. Right? So you have packages now. Let's go and see how to install. In order to install Hadoop, see what I'm going to do. Sudo apt-get install, and I'll write here Hadoop. That's it. Press enter. It will make Hadoop files available on your system. And please understand, till here you will be doing it on all boxes irrespective of whether it is master or slave. Okay? These files must be there on all machines. So you can do it on one and then you can push it on rest of the boxes as well. Okay? It's clear? Krista, is that clear? Stephen? Okay. Julio, is that clear? Right. So what I'll do now? Next is I need to go and confirm it. Yes, I have now Hadoop version with me. Right? For that, what I'll do, I'll just go and write Hadoop and write here version. This tells you which version of Hadoop you are using. And if you see, you are using Hadoop 2.5 provided by CDH, which is Cloudera distribution, hot and work distribution, a Cloudera distribution. Okay. Fine. Now this task has to be done on master, it has to be done on slaves also. Once you have done till here, then you have to decide, let me go and make this node as master, for which you have to go and edit configuration files. Right? So let me show you where those configuration files will be there. I'll go to conf.empty. Sorry. now I'll do ls. These are the configuration files which you have to configure. So if you see HDFS site.xml, mapred site.xml, then you have core site.xml, you have yarn site.xml. So these are various XML files that you have to configure. So assuming that I want this box to be master, you know what file I will configure? I will configure core site.xml. So core site.xml is for what? Configuring master, telling that this is what is name node. Then what about data nodes? That you will configure where? In HDFS site.xml, where you will specify what will be the number of replicas and all which will be created. And then you have mapred site.xml, where you will configure your job tracker and task trackers, right? And if you want to use Hadoop 2.0, you will be using yarn site.xml. Okay, right. So now Hari is asking a question. I have a question. Let's say if I have to build a new Hadoop environment and have 100 systems, are these tools? Yeah, there are tools, Hari. Right? You can do SCP in order to copy it to multiple sources. Okay? Right? So you have tools in order to push this. So you need not worry. You need not download and install it everywhere. Yeah, Nil, meaning of SDFS is now your file system will not be on a single box. Your file system will span multiple boxes, where one box will have name node component which will manage rest of the data nodes. Okay, yeah. Now you are asking me that does Hadoop interface looks the same with all OS? Yes, Nil. Interface will look the same. Okay, these files are not going to change, whether it is Hortonworks or whether it is Cloudera or whether it is Apache, Pentaho, Pivotal, HD, right? These files are going to be there. Okay, and when it comes to interfaces, yes, default interfaces which are there with core Hadoop, they are not going to be different. They are going to be same. This is how actually you will start working with Hadoop. Now after doing this, again I will do what? I'll take out history of command and I'll paste it so that you can go and you can do the same. So this is what is the process in which actually we conduct trainings, right? So I'll just end here because time is 11. It's time for you to take dinner or to sleep. I'll ask Anthony to join in and take over from here. If you have any questions, you can ask me. When it comes to coverage, just to be brief, we will cover Hadoop, HDP and Cloudera. We will then go to NoSQL. In NoSQL, we will cover MongoDB and Cassandra, and then we will move to use SOLR, because you know, if you have huge data, your search need to be better. Okay, so in order to improvise your search, you have SOLR. Hari, MapR also we can do. We will take it as a case study if you need it. So what normally I do, I work with two flavors and then I distribute case studies to people. They will come and they will do the task and we will discuss it in a class, right? This helps us to actually cover more flavors of Hadoop. So as I told you, some are demonstrated, some are given to you in form of assignment, and some are case studies, right? And when we give you as an assignment, we ensure that we provide you the right set of document to do that. Okay, so any confusion you have, any other questions you have, you can ask me.
Yeah, what are the top tools you can cover, like other data processing?
Okay, see, when it comes to Hadoop, right, Hadoop comes with the ecosystem. So I'll be covering Pig, I'll be covering Hive, right, I'll be covering Storm, right, and when it comes to what all are new initiatives which has been taken in Hadoop, I'll be talking about Sage and Stringer also, right? You know, Stringer has made execution 100 times faster as compared to MapReduce. So I'll be talking about those tools which are popular in market. Apart from that, we will also talk about Scoop, HBase, right? So you need not worry. Whatever ecosystem products are prominently used, right? We will be covering that. So at top level, I told you Hadoop, plus
Yeah, one more question. Do you have any server to set up each and everyone can use those servers, or we have to install manually in our laptops?
no, we have a server. We use Amazon EC2 in order to set up and give boxes to people.
Okay, thank you.
Okay.
That is very useful to me.
Yeah, so that we do. We have our own data center. So sometimes we use that data center also if space is free there. Yeah. Julio, any other questions? Kundan, Madhur, Pavan, Rene, Stephen, you have any questions? How are starting jobs like? You don't worry about that because I'll make you work on 2-3 case studies. So getting a job will not be difficult. And believe me, there are lots of quality manpower needed in big data domain. Companies like EMC and all are also not having sufficient manpower. Right? So I feel that job will not be a problem. I want you to start as administrator and architect. I don't want you to go again and write Java programs. That's what is my objective. But yes, it depends on the opportunity. Lois, you have any question?
Are we discussing any Java concepts here?
Yeah, we will talk about MapReduce, and MapReduce programs are written in Java, Python, various other languages. I feel that you will get Java videos in case if you are not aware about Java, that will be provided to you by Anthony. He will give you Java videos so that by the time we reach there and start writing programs to do analytics in Java, you are up with Java. Okay?
Okay.
Right. So usually what we do is,
Yes, total how many hours of session?
it is 40 hours of session plus 20 hours of case studies and all. Right? Because
Once again, it's noise is coming.
complete fast. But what you can say 40 plus 20. 40 is session, 20 is for case studies, projects and all. Yeah, Madhur. Statistics is used in data analytics, but you have tools which have taken care of it. You need to just know the algorithm and supply the value. Internally, all will be taken care. For example, Mahout is there or R Analytics is there. All these are tools which have come up where you need not, work at that particular. Viraj, Java, because Hadoop is written in Java. Okay, Viraj is asking Pig or MapReduce. It will not be. MapReduce is something which is native, which is understood by your Hadoop. Pig is to simplify, because probably if you are not aware about Java, you will look for some tool which provides you a simplified way of writing program, right? And there actually Pig comes into picture. So Pig is nothing but it's a simplified way of writing MapReduce. At the end of the day, your Pig will get translated into MapReduce programs.
Hi, this is Chandni. I had a question.
Yeah, please.
So will the training be easy to follow even if you don't have a programming background?
200%, yes. You can follow. You are following whatever I'm doing, right?
Yeah.
And it's fine, you'll follow.
Okay, thank you.
Because there are, Viraj, MapReduce is used in industry, but now dimensions are changing. You have many other algorithms. As I told you, Tej is there, Storm is there, Stringer is there, right? So there are many other algorithms are coming up.
Okay, because I thought Pig is a like easy language for like you.
It's an easy language. It's an easy language, but Pig gets translated into MapReduce internally.
Yeah, internally it gets translated into MapReduce.
Yes.
But
errors and all that you will get, right? It will be MapReduce errors. So you cannot avoid knowing MapReduce. Low level errors when you will see, it will be MapReduce errors.
Oh, okay.
It simplifies writing, you say, functions and code for analytics.
It takes less effort, like you need to write just 5 to 10 lines of code for.
Obviously, yes.
Yeah.
You have big parser which translates later into MapReduce programs.
Okay.
Okay. So, any other questions? Yes, you'll be getting material also from us. For example, if you see this is Cloudera material which covers all these topics. Big data, Cloudera, planning, understanding, HBase, securing, name node, high availability, troubleshooting, and planning for production environment. So similarly for Hortonworks also, you will get a concise material. And apart from that, the small tool files which will have all the commands so that you can copy paste and you can work and you don't have a spelling typos when you're writing commands.